Question 21. This is a cyclic simultaneous equation question. So first of all, you need to convert the question into simultaneous equations. All the eels are electric eels except 12, which means the moray eels and the freshwater eels adds up to 12. And for the same reason, E adding F is 14. M adding E is 16. So if you combine the three equations, add them all up, you have 2M adding 2E adding 2F equals 12 adding 14 adding 16, which is 42. So M adding E adding F is equals to 21. All right. So that's the answer. And for the next one, Jaron always cycles to work, leaving at 8 a.m. every morning. When he's averaging 15 kilometers per hour, he's arriving 10 minutes late. But if he is averaging 30 kilometers per hour, he's arriving 10 minutes early. So let's say the speed are 15 and 30. It means the time is going to be x and 2x, right? So the difference between x and 2x is 20 minutes, which means that this x is 20 minutes. This 2x is 40 minutes. So the distance is equal to 30 times 20 over 60, which is going to be 10 kilometers. And the time required, because he's 10 minutes early if he's driving only for 20 minutes. So the time required is 20 adding 10, or 40 take away 10. That is 30 minutes. So it means that Jaron has to travel 10 kilometers in 30 minutes, which means that every hour he can travel double of that, which is 20 kilometers. All right. As for question 23, so it says that Sid is coloring the cells in 4 colors, such that 2 cells that share a vertex are colored differently, which means that, for example, I have a vertex right here. These 1, 2, 3, 4 are all going to be different colors. So it means that once we know 3 different colors, I know the remaining one for any grid of 2 by 2. So what color will he use for the cell marked X? Let's see. First of all, I have blue and yellow on both sides of this square, right? So it means that this square in the center is either red or green. Well, let's say red. And then once I know that I have blue, red, and yellow all sharing vertices with this box, it can only be a green one, right? So it means that this has to be a green one. And then, of course, red, green, yellow, which means this is blue. Yellow, blue, green, which means this is red. Blue, red, green, this is yellow. Red, blue, yellow, this is green. And then following this pattern, yellow, green, blue are all next to or sharing vertices with this box down there, so it has to be a red, which means that this is just repeating itself as the first row and then repeating itself as the second row. Okay, so the question mark will be marked as red. Then question number 24, it says that there are 2 ponds at the bottom of Gabriel's garden, each containing frogs and toads. In one of them, the frog to toads ratio is 3 to 4 and the other has 5 to 6. Suppose there are 36 frogs in total. What would be the greatest possible number of toads in the ponds? So first of all, we need to see that which ratio is giving more toads. The first one is giving 1 extra toad for 3 frogs. The second one is giving 1 extra toad for 5 frogs, which means that I want to have more frogs in the first pond than the second one to give the largest possible total. So it means that, well, I want to have the smallest possible number for the frogs in the second pond, but then since both ponds have frogs and toads, the second pond can only have, well, if the second pond has 5 frogs, it means that the first pond has 31, but that's not a multiple of 3, right? So it means that we need 3 times the first one, adding 5 times the second one equals 36. So like, how many parts can you take? So after the analysis, let's say first and second. After the analysis, you can see that this is a multiple of 3. 36 is a multiple of 3. So 5s has to be a multiple of 3 to make this indeterminate equation work, which means s is 3 because 5 is not. So when s is equal to 3, it means that there are 15 frogs in the second pond. So 15 to 18, that's the ratio for the second pond. And then there will be 21 frogs remaining in the first one. So that's 21 to 28. There will be 21 frogs left in the first one. So altogether, 36 frogs, right? And for toads, it's 28 adding 18. That is going to be 46 toads. So the answer is B. And finally, 2019-25. So the room numbers of a hotel are all 3-digit numbers. The first digit represents the floor and last 2 digits represent the room number. It has rooms on 5 floors, 1 to 5, and 35 rooms on each floor. So it's numbered N01 to N35, where N is the number of the floor. So how many times will the digit 2 be used? We can classify it by digits. First of all, for each of the floors, there will be 01 to 35, right? So for the ones place, the 2 is going to happen 4 times. For 02, 12, 22, and 32. So 4 times each floor. And for the tens place, how many times is that going to be used each floor? We can see that, well, there's a zone of 20s, right? So from 20 to 29, it has shown up 10 times in each floor. Not flower, in each floor. Does it make sense? And then finally, the hundreds. Well, the hundreds is a little bit special because it represents which floor it is, right? So it only shows up in the second floor, where it's going to be showing up 35 times, from 1 to 35. So in the end, how many times will the digit 2 be used? It's going to be 10 adding 4 for each floor, times 5 floors, adding 35. So we have 70, 14 times 5, 70, adding 35, that is 105. So the answer is E. That's the last question for this paper.